Okay, so now that we've taken a look at some problems involving these arithmetic and geometric series, it's now time that we look at the next part of this course, which is summing them up. So we're going to start with arithmetic series. I'm going to break these into two separate episodes. So arithmetic series and then geometric series. Now you'll see there's two formulas on the screen, and they look seemingly different, but you'll actually see that they're very similar in a minute. There's two formulas that we use. The first one is when we know the last term of the progression. So say I want to sum up an arithmetic progression, and it's 1, 2, 3, 4, 5, all the way up to 1,000,000. Right? That'll be quite painful, and it'll be a very big number, but it would be doable, and we know the last number. And so this is the formula that we use for that. We use a half times n, and then in brackets a plus l, where we have the first and the last terms. Right? We have this other formula, and so sometimes we don't know what the common difference will be. So sometimes we want to sum up all the terms of a series, and I just give you 2, 4, 6, 8, and I tell you I want you to do the first 100 terms. But I don't tell you what that last number is. In that case, we'd use this formula here. Now it looks different, but I've written this formula here. That was the formula we looked at before for the general term of an arithmetic series. If we substitute that in instead of L, then it makes sense, right? Because if we use L, that would be using the full n, so a plus the difference n minus 1 times to get to the last term. If we bring that in here, that's how we end up with this. It's a plus n minus 1d, which gets us 2a plus n minus 1d. So my point is these formulas are exactly the same thing. It just depends on what you're given and what you need to find. That's all. We just need to practice applying these formulas into some practice questions, and that's what we'll do now. First question here says to find the sum of 2 plus 4 plus 6 plus all the way up to 1,000. So a little bit more sensible than the one I was saying before. But there's a few things we need to think about here. I'll copy down the formula that we need. You can see we're given the last term, so we're going to use this first formula, which is a half times n times a plus l. Now, we're given our first term, which is 2. We're given our last term, which is 1,000, but we're not necessarily given n. Now, there's two ways I could do this. I could plug everything into this formula, and I could find my n that way. There'd be no problems doing that. But I can do this a little bit quicker. I can look at this and I can go, well, this is essentially the same as counting up to 500, except I'm counting in twos, 2, 4, 6, 8, instead of 1, 2, 3, 4. So if I'm getting up to 1,000, that's the same as counting 500 times. I'm just going up in twos. So without actually using any formulas, I actually know that I've got 500 terms here. So I write down everything I have. I have n equals 500, my a equals 2, and my l equals 1,000, my last term. And so I say that the sum of those terms is half n, so half times 500, which is 250, sorry, and a plus l, which is 2 plus 1,000. And now this, if I get my calculator, gives me 250,500. So that's the sum of all that series. You can see that's a reasonably large number, but it makes sense. I'm adding up all these numbers up until 1,000, so it makes sense that it's quite a big number. All right, moving to the next one. Find the sum of the first n terms of the series, minus 9, minus 4, plus 1, so on. Now, this one's a little bit different because I'm not actually given an n. I'm actually asked to give an expression in terms of n, and that's what I'm looking for. So I'm going to use that second formula, this one up here, where I've got Sn equals a half n times 2a plus n minus 1d. Now, if I think about what I'm given here, all right, I'm not given the sum, I'm not given n, that's okay. I've got my a, which is minus 9. I've got my d, which is the difference between the terms, so minus 9 to 4 is 5, minus 4 to 1 is also 5, so now I've got my difference of 5. That's all I have, all right? So I'm going to write S of n, so the sum of the first n terms, is a half n times 2a, which is minus 18, plus, I'm going to bring the d out the front just to make it nicer, 5 times n minus 1. Now I can clean this up a little bit, and I can leave that half n out the front. Now in these brackets, I'm going to have minus 18 plus 5n minus 5. So I'm going to do minus 18 minus 5, and that'll get me minus 23 plus 5n. All right. So that would be my expression for the sum of the first n terms. And now that's okay that it's not just a number, right? I'm not finding a number because I'm not given enough detail, right? It's asked me to find the first n terms. And so if you wanted to find the first 10, 20 million terms of this series, you would just substitute that value in for n, and that would be all you would need to do to get that sum. So I've got a generic formula there. All right, looking on to the third question. This one's a little bit more practical. Right, this is a real example, one that you'd see on a test. So logs of wood are stacked with 10 on the top row, 11 on the next, and so on. If there are 390 logs, find the number of rows. All right, I'm just going to rewrite that formula there, just so you have it. Okay, and we need to think about what we're given here. Now, it's not as clear in this case, because I'm not just given the set of numbers like I have in the other questions. That's okay. If I remember, my A is my first term. And if you remember what this example, if you think about what this example is actually going to look like, it's logs will stack in a triangle. So I'm going to have the lowest number on top, and each row they're going to add one more. Now that actually gives me my A and my D in the question. So I have A, which is the amount on the first row, which is 10. I have D, which is how much each of them are changing by, which is going to be 1. And then I also actually have S of N, which is 390, the total number of logs for this N. So in this case, I need to find N, and I have everything but N, which is fine. So I have 390 equals a half N times 2A is 20, plus, again, I'll bring the D out the front, but it's just 1. So it's just plus N minus 1. Okay, so I have 390 equals a half N times 19 plus N. Now I don't really like that half, so that it's stopping me expanding all this out really nicely, so I'll just times by 2 on both sides. So 780 equals N times 19 plus N. And I want to expand this all out because I see that I've got something that I can't really solve for N yet, so I'm going to factorize the entire quadratic. And so this right-hand side becomes 19N plus N squared. Then I'll subtract the 780 equals 0. Now at this stage, I'm just going to write the factorized form. If factorizing is something that you struggled with, then that's a topic in year 11 that you'll need to go back and sort of get a little bit better at. But what I'm looking for is two numbers that add to 19 that multiply to minus 780. Now, you can just experiment with those numbers if you need to, but those numbers are 39 and minus 20. And so I can write it like this. All right, and that's equal to 0. Now, using the null factor law, which you should know from factorizing as well from year 11, I have 20 and minus 39. Now, obviously we're talking about the number of rows of logs. So one of these answers makes just a little bit more sense than the other one. But I can't just write this, because this still is a valid answer to my quadratic. All I need to say is because N is greater than 0. That's all I need to say. What I would normally say in an exam here is I go, well, just what I said really, is we're counting the number of logs, the number of rows of logs, and so it doesn't make sense for this to be a negative number. You'll come across all these things like number of something, height, weight, all these things that don't make sense to actually be a negative number. You always just need to justify that, right? So because my N is 20, again, the question doesn't say what is the value of N, it says find the number of rows. So the last little change I need to make is therefore we have 20 rows, right? So that was summing arithmetic series.